Hello and welcome to the second video on the beta testing troubleshooting series. In this video we will see another of the common problems some of our beta testing are reporting, which is that when connected to long chains, some of the KCeptors are not read properly. This problem seems to be associated with this particular type of cable, which is the type of cable we delivered on our second beta testing program. We previously used to use this other type of cable, which is manually done by stripping off the jacket of a multi-core twisted pair cable and then crimping the connectors. And we are still getting much better results with this cable, as I will show you later. Please keep in mind that what we are dealing here is prototypical hardware. This is what the beta testing received on these programs, and these problems of lectures of the KCeptors on the cables will completely disappear with the next generation of Chordata hardware, which will have a completely redesigned data transmission bus. Okay, but since the beta tester already have this hardware at home, it's a good idea to see how we can still get proper readings with this. Okay, so in order to simulate a long chain, I created this. This is a 3 meters cable made with a parallel type of cable, and this is also a 3 meters one, but made with the twisted pair crimped jacket manual made one. Okay, so I will turn off the Raspberry in order to connect the KCeptors. Remember to do this on all times, because this is one of the operations that might get your back converter burned down. And I will connect one of the ends of this long cable to a KCeptor. As you can see, this cable is not flexible and it tends to move your KCeptor around, and this might also influence the capture. Okay, so now let me plug the Raspberry to power the system. I am using the alternative power source, which comes directly from the Raspberry, as explained on the previous video. And now the Raspberry is starting. Okay, after letting it boot and then connected to the Raspberry through SSH, I am now into the Raspberry, and I will show you how, if I use the scan flag to scan the available sensors with the notochord, I get an error. It is not even able to finish the execution. Let me show you what happens if I unplug this KCeptor, first disconnected this long cable from the hub. Okay, as you can see, it is not finding any KCeptor because there is not connected, but it is working and it is able to complete execution and scan all the gates of the hub. So I will now turn down the Raspberry and connect the KCeptor using this other cable. Okay, here we are again. I connect this KCeptor with this long cable made of twisted pairs with stripped jacket, which is the type of cable that works fine. As you remember, seconds ago I was using this long black cable and I got several errors. But now if I execute the notochord with the scan function, as you can see, I get to properly read these KCeptors with a long cable, but just a different type of cable. Again, this is just a workaround for the current hardware. These problems will disappear in the next release, in which, by the way, we will be changing the connectors. We will be using RJ45 connectors, which are the ones that are normally used in Ethernet ports. The nice thing about these connectors is that there are plenty of commercially made cables available, industrially made cables available in the market, and many of them have twisted pair cores with really flexible jackets. So this will be a great solution for the next generation. And as I said before, the bus will be revised. We will be using a differential bus, so it will be much more strong in terms of communications on long chains, and also in electromagnetically disturbed environments. So that's the video for today. See you in the next one. Bye.